y, it's at negative 40. 1, 2, 3, 4, 5, 6, 7, 8. If you did 4, yours will be at 10. You can obviously adapt as to where yours should be, right? So they want you to label them, so I would go negative 40 and try again. Not do that. 0 and negative 40. Or off to the side, you could just say y-intercept at 0 and negative 40, giving the key points as well, right? You could label it and then put it over there. What's the mins and maxes at? Anyone have them? Negative 40? Is it? I thought it was a little more.
It's like negative 46.
Yeah, it's negative 46 and some x. What's the x? Positive? Something like here. Anyways. And you should label it. Does everyone have that minimum down? What is it? What is the coordinate? Do you have the coordinate written? So negative 40?
45.9 is like rounding to the nearest area.
Okay, and then what was your x? Sorry, I didn't listen.
0.66.
And then you could say your minimum is at 0.66 and negative 45.9. Are there any maximums in here?
No.
It just comes down. Are there any actual high points in there, though? There should be. I'm going to type it in. If you didn't find any of these, you should type it in so that you do find these. So there is a little maximum above the x-axis. It's not actually, so if I go negative 40 and make my y max 10. So if you go and actually make your y minimum, I would type it in to practice for yourself. Because you know this has to go and make some sort of a W, right? There's going to have to be a maximum in it. There can't just be a minimum. And often it's not actually on the x-intercept. There is one, because there's the negative 4 there. But I'm going to make my y minimum negative 50. My y max 10. My x min negative 10 and 10. I'm not changing those. So I have a maximum, second trace max. Enter. I have a maximum at negative 3.03 and 1.25. This is for my own welfare to draw it more accurate, right? And remember, you have to remember the whole time that your y scale is 5. So what I find people will do is they'll go to negative 3, and then they'll go to 1.25 and put it here. But that's not 1.25, that's like 6, right? So it's just above. That's not the most accurate. It should be just over it. Okay, then I know I have x-intercept. I have x-intercept at negative 4. And there's 2 of them there. So I'd say x equals negative 4 multiplicity 2. And then I have one at negative 5 over 2, which is negative 2.5, and 2. And those you don't have to write the multiplicities. So 4, negative 2.5. That's 1, 2, 3. Oh my gosh. Why didn't you guys correct me? That's not 3. No one corrects me. 2.5. And then 2. Now, can I just wing it? Is that accurate? To just wing it from this point? Now, there's also this great thing in front of you. It's a calculator. So we're going to go second table, and we're going to pull more points off of it because there's more points. So like -5 and 8.75. Now, if you look, I'm going to show you something. -6 is it's at -6 and 56. Well, 56 doesn't fit on my chart, right? It would be off of it because I made my y scale be 5. But negative 5.5 would fit. So if I want another accurate point, I don't have 5.5 on my table, do I? No. But how can we find an x value that's not on our table? We go second, trace, and then value. And then you can put in any x value. So I'm going to put in -5.5. And I get 25.3. 2, 3, 4, 5.5, 5, 10, 15, 20, 25. Then I at least have more of an accurate arm. I'm not just like winging it. Okay? Yeah.
You have to label those points?
No. The key points are your y-intercepts, your x-intercepts, your mins, your maxes.
And on the diploma, if you label it like that, is that acceptable or do we have to?
So I always label like the actual words off to the side, and then on here I would like label it with a coordinate. Yeah, just so the coordinate's with it. But you don't want to write x-intercepts and then like right beside it. So I always label it and then I label the graph as well. And then this one comes up to here and then back down to here and then it comes through. Now if I want to pick some more accurate points in there, I can go to my table and I have -3 and 1.25, -2 and -4. So it would be somewhere here. -1 and 20, -20.25. 5, 10, 15, 20. So it'll be here. So that's going to come down and go through there. That is terrible. Pretend that those go through the coordinates. Because they didn't. And then, do as I say, not as I do. That's what this is. And then -1 and 43.25. So it's like here. And 43. And then 2 and 0, and then 3 and 134. We've ran out of room. So I'm going to try second trace value 2.25 and 23. So at 2.25, I'm at 23. 5, 10, 15, 20, 23. Somewhere in there. Do you see how I picked more points in between to make it a little more accurate? Yeah? We agree? It says accurately sketch the graph, so I would label all my points. State the domain and range. What's my domain? X such that X and M of the reals. That is what notation? Set notation. And then interval it would be? And if they don't specify, you can give either and you are not wrong. You could give your domain and set and your range and interval if you really want it. That's weird, but you could if they don't specify. Often they do though. And then your range is going to be y such that y is greater than or equal to -45.9 y-yard or -45 point, common infinity. Yeah.
How are we supposed to round that number? Like, if we don't get to what it's they want it rounded to?
If they don't specify, you can't be burnt on that.
Okay.
Yeah. So I usually do 2 a 10, but if they don't specify, how do you know, right? You could go -46, they could go -45.9. Yeah. And then determine the zeros. Well, the zeros are right here. And you have to make sure you say multiplicity 2, right? Or you're not getting the mark. Then we're going to flip over. So we went through and we said the equation of this one So the key thing when you go to give equations, you have to label what the heck you make variables be. So up here, there's like x's, which is good. They gave us x's, so we don't have to label what the x is. But if we're making volume, let's say, is there anywhere up here that says use v of x or f of x or anything like that? So if you are sponsoring a new or adding in a new variable, you have to let them know what the heck it is. You can't just be like, it's v of x. Of course they know that's the volume, right? Oh, it's f of x. Of course they know that's the volume. So you have to say, so I'm going to use v of x. You could use whatever you did use. I'm going to say, let v of x represent the volume. So the moment you put in a new variable that is not in the question, it wasn't given to you. Like they gave me the x, right? So I don't have to say let the x represent blah, because the x has been given to you. But I do have to do it with the v of x because I'm giving you a brand new equation. So I'm going to do v of x equals 20 minus 2x for the length times 10 minus 2x for the width times x for the height. You could, if you wanted to, you could say let x represent the height if you felt the need. Now here it says sketch the graph of the function and state the restriction on the domain. So you'd have to do a sketch of it. This is going to be the worst sketch known to man. But what do we start at? Yeah, 0, 0, right? If you have 0 volume, you're going to have 0 of everything, correct? And then you go up to something, and then you come back down to 5, I believe. What's the something up here? 2.21, I believe, and something. I don't remember what the other part is. 43.9. Sorry?
192.
Oh, I was really off. 192.56. I'm going to go 0.6. Oh, it says 100. I'm not going to do it. No, it says cubic centimeter. Okay, well, it's not actually asking for that, so it's okay. So I did a really bad sketch because I didn't do any more points. Do I need to do more points if this is accurately on a test? Yes. And they will give you an actual graph to sketch, right? They wouldn't just be like sketch with B. They'll actually give you a Cartesian plane, and I would give you one on the test. Now here it says determine the value of x to the nearest hundredth of a centimeter that gives maximum volume. This here, if you see maximum or minimum, that screams find the maximum or the minimum. Okay? People are like, I'm not sure what it's asking me. Well, if it says max or min, at the very least, go find the maximum, right? Then it says determine the x value. So the maximum x value would be what? 2.21 what? Centimeters. What does the 192.6 represent?
Maximum volume.
Maximum volume. So I asked you for the maximum volume, you'd say 100, it's the nearest tenth because I rounded it that way. 192.6 centimeters cubed. You have to have cubed, right? Watch your units. Boom, there it is. So the nearest centimeter. So what's that going to be? 190 near centimeter cubic. Centimeters cubed. In AP, unless specified, in actual AP exam, they round to 3 decimal places always. There's a random time where they're like, it's the nearest tenth, just randomly, and I don't know why they do that, but other than that, they don't specify, and it's 3 decimal places. But for 30-1, they always specify. Yeah.
For A, it's determined expression, not equation, so we have to do it.
Actually, yep, you would have been okay. Look at you reading properly. You wouldn't have needed this. Because it says expression. Expression doesn't have an equal sign. Hero cookie to you. Actually, yeah. You and I would have gotten this wrong. I think Maylee might have been the only one who would have gotten it right. Did anyone else do expression properly? Oh, look at you readers. I'm so proud of you. I suck. I'm just an equation. So, in turn, if you just happen to not put v of x because you lucked out and you didn't see expression, which might be the case, this is a good learning curve for both of us because I just put an equation because I didn't read it quickly. I just was doing it. If this says equation, you have to have v of x equals or you won't get the marks. If it says expression and we did what I just did, we'd lose probably 0.5, I would bet. Which would suck. I would have not got a full mark there. Because I didn't read. I was so excited. Okay, so if it says equation, you need variable equals and then blah, right? If it says expression, you do not need that. Not only do you not need that, you shouldn't have it. Right? Good job. So proud of you. Gold star. If I had one, you would be getting it right now. Yeah. I need gold star stickers. I'm getting some. When you did 20-1 and you went through it, I think you didn't do all the transformations. I think you just did, you might have done more, so just correct me if you didn't, but the 20-1 transformations are the horizontal translation, the vertical translation, and then you get a vertical stretch in front, and then you get a reflection in the x-axis. Did you guys do, I don't think you did, horizontal stretches and reflections in the y? No. Showed it to you? Okay. Because that's the grade 12 stuff. So it doesn't make a big difference. You just need to know that what doesn't affect the vertical, what affects the vertical affects the y, and what affects the horizontal affects the x. That's the only difference. So we're going to go through these ones. So, wait for now. So a reflection is a mirror image about a line or axis. In the old curriculum, you actually could reflect not just about the x and y axis. They used to make you reflect about x, like the line x equals 3 and the line y equals 2, and then you'd have to reflect on both sides of that as well. But that's outside the scope, and if you look in your curriculum, it'll say that. The only axis we're allowed to reflect on is the x and y axis, or the line y equals x, which will get us inverses. We're not allowed to do any other horizontal or vertical. It says it in the actual curriculum. So they changed that. So here, it says reflections in the x-axis comparing y equals f of x to y equals negative f of x. So this is my graph, y equals f of x. F of x equals x squared minus 4x plus 4. Now this isn't in the actual sitting perfect transformation style, right? Transformation style is I have a bracket with all my x's in it, and I maybe have something at the back, right? The something's in front and at the back affect my y's. What's in my bracket affects my x. We agree? This one's in nice old standard form, which is only helpful to get you your leading coefficient and your y-intercept, but it doesn't help you quickly get your x's or anything like that, right? Now, we know that y equals f of x is this equation. Now here they're saying y equals negative f of x. What the heck does this mean? If you saw that in math, negative in front of something, what does that mean? Pardon? The whole thing's negative, which means I'm multiplying by a negative 1, right? When I have a negative just sitting in front of a bracket, or a negative sitting in front of an f of x, it just means the whole thing gets negated, correct? Same thing's going to happen here. My whole thing. So I'm going to replace my f of x with negative f of x. So this baby's going to get replaced with negative f of x, right? So I'm going to get negative f of x equals x squared minus 4x plus 4. I could look at it that way. Or I could say, hey, I negate all of f of x. So I could say f of x equals, and this is f of x, this. Both of which work because I could divide the negative over and it'll change it all. Or I can distribute the negative in and it'll change it all. Right? So this, if I distribute it in, I get negative x squared plus 4x minus 4. Let's compare without even typing them in our calculators. This one's x squared minus 4x plus 4. It's a quadratic. We know that, right? Leading coefficient is positive, so I know this graph is what? Yeah. Up on the right and then up on the left because it's degree 2, right? It's concave up. We agree? And my y-intercept is the constant, which is 4. Now, my leading coefficient is negative 1 now, so it's actually concave down, which causes it to be like this and to do this. What am I mirroring on? The x-axis, right? And then my y-intercept was at positive 4. It's now at negative 4. What am I mirroring on? The x-axis. So it will affect the y values, correct? But when I affect my y values, I actually reflect on the opposite axis. I reflect on the x. Because if I take a positive 4 up here and I move it down to a negative 4, I'm reflecting on the x-axis. So every time you're moving y's, You are physically moving y's. You are physically multiplying all your y's by -1, but anything down here in the bottom quadrants is now going to be in the top, and anything in the top quadrants is now going to be in the bottom, so I'm reflecting on the x-axis the whole time. Correct? So when it affects the y's, it actually is reflected on the x. It's always reflected on the opposite axis of the variables it affects. And you don't want to memorize that, you want to understand it. Because you memorize it, you might flip it, right? But if you understand it, you'll never flip it. So if you're wondering, okay, I'm going to multiply all my y's by -1. If I have a 7, it's now going to be a -7. Oh, that is the x-axis. So if you understand it, you won't make mistakes, right? But memorizing causes for mistakes. So we don't want to memorize, we want to understand. So if we multiply our y's by -1, they're going to reflect and flip over that x-axis. Okay? So, we're going to skip this part. We're going to go down here. So, actually we're not. Go sketch it. You have a calculator, it's quick. Sketch y1 and y2. y1 is going to be x squared minus 4x plus 4. Do I actually need to type y2 into my calculator? No, I just need to take every coordinate from y1, keep the x's, and negate the y's, and it'll give me the other one. So actually you only need to sketch y1. And if you want your calculator back to the standard window, zoom 6. Remember? Zoom 6 takes it back to -10, 10, -10, 10, and you don't have to do it. Zoom the middle top button and 6. I also know I can quickly factor this. If I actually factor this, I'm going to get x minus 2 squared, so I know I'm going to have a point of tangency at 2. And I know I have a y-intercept, bless you, at 4. 1, 2, 3, 4. And I also know that parabolas are symmetrical. So if this is 2 over and 4 up, this is going to be 2 to the right with 4 up. Is this the most accurate sketch you've ever seen? I only use 3 points. Is it the most accurate sketch you've ever seen? No. You could pick more. Please try and round it down here. Don't make this a mountain. Make it rounded, because rounded is the point of tangency. If you do a point, that's actually an absolute value. Remember points, absolute values make those V's? This is not a point. So don't go like making this like a straight, because that point, if you make it, is not a point of tangent. It's not the point of tangency we need. We need it to curve a bit. Okay? Now I want to draw y2. So this is my y1. This is my y equals f of x. I want to draw y2 without using my calculator. I'm going to use a different color. So I got -x squared plus 4x minus 4, or I could have just written it as this. And it would have been sufficient. I don't need to type it in my calculator though. So this coordinate here, we're going to show you. So, what's my mapping? xy becomes, did anything happen to my x's? Is there anything in the bracket with my x's? No, so my x is staying the same. What's happening to my y's? They become negative. So that would be my mapping if there's just a reflection in the x-axis, right? Now I can actually prove every single point to get the red ones. So I have 0 and 4. It's now going to become 0 and -4, which is true. Because I know that the constant at the back, once I distribute it into my brackets, because you can't give a constant until if there's brackets, right? You can't go by the constant unless the brackets are gone. So that's why I can't say my y-intercept is 4 when I look at this one. I have to look at this one because it's the one without brackets, right? So I drew that one. Then I have 2, 0, and it's going to become 2, -0. Is there such a thing? No. And then I have 4, 4, and it's going to become 4, -4. Did I need to actually put the other one in my calculator to figure it out? Nope, because I know it's a reflection of the x-axis. Yeah.
How do we know which points we have to map? Like on the graph?
So you pick every point.
Okay.
Yeah. So if you drew 10 points, you take 10 points and map them and flip. Yeah. And the more, if this is a diploma, I'm picking more points. I'm not just doing 3 when it says sketch. I'm going to pick more. But at minimum, you need 3 on a parabola or you can't actually draw it. Okay. What stayed the same?
Minimum/maximum.
Minimum/maximum, and in this case, it's also the what? The x-intercept. Why did it stay the same?
0.
Yeah, because it's touching the x-axis, because y is 0, because y is 0, and if I multiply 0 by any negative number, it stays the same. So the only time your x-intercepts will not stay the same is if there's a horizontal translation, or a vertical translation for that matter, because you add to 0. When you add something to 0, it changes, or when you subtract something from 0, it changes, correct? So vertical and horizontal translations will move your x-intercepts all over the place, right? But vertical reflections, or reflection in the x-axis, or vertical stretches, which we're going to multiply our y's by, aren't going to change our x-intercepts because our x-intercepts are 0, and when you multiply by 0 by anything, it stays the same. So x-intercepts are only changing if we have vertical and horizontal translations, or we have horizontal reflections or stretches, right? Because those can move my actual x value, but my y on my x-intercepts is 0. So if the y is multiplied by anything, it's staying the same. So that's called an, I didn't need to do that. That's called an invariant point. Invariant point, I didn't do anything. Why did it just, hates me, ghosts. Okay, invariant point. Invariant points are the points that do not change. I should use the word coordinate because that's actually accurate and proper. Now, it means does not change. It means it was there, it's still there. It does not mean it was there, I rearranged the graph again, and another point on that graph actually moved to it, and it's still there. That's not invariant. That means the point moved onto that same point. That's not invariant. Invariant means I had the point, I did all my mapping and stuff to it, and that baby stayed. That's invariant. So the only invariant point here is 2, 0, or the x-intercepts. How? Sorry?
Can we write that? Do we have to say multiplicity too?
Nope. But you can. There's no harm in it. How does the graph of y equals negative f of x compare to the graph of y equals f of x? It's a reflection in the x-axis because it affects the, reflection, no s. So, between grade 11 and 10, or grade 11 and 12, sorry, not 10, grade 11 and 12, the difference between grade 11, you were always given an equation, you could always type it in and you could kind of sketch it off your graph even if you were kind of lost. It would work for you. Grade 12 will just give you a graph without an equation. So if you don't know how to actually change a graph, you can't type it in and just redraw it. Okay, there is no equation here. This is just saying, here is the graph of y equals f of x. It is shown. Sketch the graph of y equals negative f of x. When the negative's in front, what is that? It's a negative y. We agree? So we're going to have x, y becomes x negative y. Why did I go straight to mapping?
Just so you can put in coordinates.
Because you'd fit in coordinates, and this is a graph. When it's a graph, it's a whole bunch of coordinates, is it not? And what I tell you, when you get coordinates, you have to move coordinates. Mapping, 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 right? So, could you just know this is reflected in the x and draw it here? Yeah, you'd say this one's invariant and this one's invariant because we know from our math that they're invariant. But remember I told you the chance of you just getting a reflection? Sometimes slim, right? They're going to put more to it. And you'll see, if they give you a stretch reflection and a translation, it's the standard of excellence. You'll see that in your curriculum too. So, if we do mapping, let's pick some random points. So I'm going to pick one off this arm. It's at 1, 2, 3, 4, negative 4, 0. And it's going to become negative 4, negative 0, which isn't possible, so it stays. Then I have negative 1 and 4. It's going to become negative 1 and negative 4, which makes sense. Remember I told you as you draw them, connect them? So I drew this one, then I drew this one, so I'm going to connect them. Wow, my drawing on straight lines is off. And then I have 1, 0. It's going to become 1 and negative 0, which isn't real. Is it the most accurate graph? Did I pull as many points as possible off that I could off of here? No, I just did a really quick sketch. But you can take points all the way along it and redraw them, right? And have it perfectly accurate. Okay, we're going to flip over. Now what's happening? I have a negative in the x's. So my mapping will be xy becomes negative x comma y. How do I know that? Because whenever anything is in that bracket, it affects the x in mapping. Every single time. Anything not in that bracket affects y's in mapping. It's if you remember that, it's very, very easy. Anything in this bracket will affect x's. Anything outside will affect y's. Oh look, there's nothing outside, so my y stays the same. My x is a negative, my x gets negated. Okay? What are you guessing? If I take my x's and I make them negative, or I negate them. So if I have a positive 2 and it becomes negative 2. If I have a negative 4 and it becomes positive 4, what am I doing? Reflecting on the y-axis this time. You can say in or about, and they accept both. Don't give any other random things that you want to make it reflect. Some people put like reflection around. Then we have to like bring the head marker over and be like, do we accept that? Is that okay? So reflection about the x-axis, y-axis, or reflection in the y-axis or x-axis are fine. So we need to write the new equation. Well, if this was in that nice transformed form, like where it was like something x plus squared minus something, we go negative x and then put it in the squared, right? But let's use grade 10 math. Do you see how every single day I go back to grade 10 math? It's just a great place to be. In grade 10 math, we were taught, when we were given this notation, so you were taught this notation, you just didn't really remember why, and the teacher just be like, don't freak out. It's just y, okay? Whenever you were given this, what did this mean? When you're given f of something in a bracket, what did this something in a bracket do? It affected all the x values. So if it was like f of 3 instead, what did you do? You put 3 in for all the x's, right? If it was f of negative 2, you put negative 2 in for all the x's. If they had, your teacher had been like a rebel and gave you like f of smiley face, you would then have put smiley face in for all your x's, right? You would have been totally okay with that. You might have freaked out a little, but you would have been okay. You would have came around to it. So now, I'm your teacher in grade 12 saying to you, oh, it's f of negative x. So what are you going to do now? Yeah, so I'm going to go into my x values, I'm going to toss them behind my head, and I'm going to replace them with negative x. And when we do replacement, it's called substitution, right? And every time we substitute a value, we should put it in brackets. That's the key thing with substitution. Because you should put it in brackets, because if you square a negative, it actually becomes positive. If you don't put it in brackets, it's not going to tell you it's positive. It's actually still negative. Okay? So we substitute, we put in brackets. So I'm going to go f of x, I guess f of negative x equals, and I'm going to fill it in. So I'm going to go negative x squared minus 4 times negative x plus 4. And I get x squared plus 4x plus 4. Wait a tick. I have the same y-intercept. What? Why? How? How's that even possible? Your x is 0. You're reflecting on the what? The y-axis. You're multiplying all your x's by negative 1. Your x's just happen to be 0 on the y-axis, so they're not going to change, right? So this is the same graph we had before, the original. It was like, it was like that. And now we're taking those points and we're mapping them to xy becomes negative x comma y. We're going to go 2, 0 becomes negative 2, 0. I don't know why I started in the middle point. That was stupid. You should always start left to right. So if I start on my very far left, it would be 0, 4, and it's going to become negative 0 and 4, which negative 0 is just positive 0. So these stayed the same. And then I have 4, 4. It's going to become negative 4, 4. See that? Sometimes they'll ask you to label your invariant. And if they ask you for key points on this, where you draw the original and draw, one of the key points would be the invariant point. They'll look for that too. It's also in your curriculum. They could say, determine the invariant point and explain why. And you have to explain why it's an invariant point. Which you could use mapping. You could say there's a reflection in the y-axis. You have all the tools in your toolbox to explain why that remains invariant. So state the coordinates of the invariant points. It's going to be at 0, 4. How does the graph of that affect or compare to that? We have a reflection in the y-axis. It's always in the opposite axis. If it's negative x, my x are being negated, so they're reflecting on the y, right? Okay, you draw the new graph. Use mapping, please. Just practice it. Now note to self, if you just pick like the x-intercepts and the y, the maximum of this, which this is an absolute value function, if you do that, you might miss the invariant point. What is the invariant point here? It's on the y-axis. So I'm going to just show it. So it's at 0, 2. It's going to be at negative 0 and 2. Which is a plus. So make sure you actually go through that, right? So you prove the point that, and then 1, 0. Because one of the most common questions is determine the invariant points. Very common. And I'm going to label this. Always label your graph. Then you're going to flip over. Move. Oh my gosh. Is it frozen? Seriously? Okay. Let's look at A. So here's a graph given to you, and this is how they do some of the times. This is how they do some of the questions in your diploma on unit tests. Is they don't give you an equation at all. They just give you a graph without an equation. There is no equation that would represent this, just so you know. Like, it doesn't even keep going on. It doesn't follow a distinct pattern. They would just give you a function. Now, it's a function because I can draw vertical lines through this whole thing, and it doesn't cross more than once. So the vertical line test is what checks for a function. So this is a function because if for every x there can only be one y, which means so for every vertical line I draw, it better only cross through once. So that for every x there's only one y. Now if I look at A has y equals negative f of x. What's the transformations that's happening? State the transformations. It's a reflection in the x-axis, or about the x-axis. Why? outside the brackets, it affects my y's, and if it takes my y's and makes them negative, I'm going to reflect on the y's. I did it the other way. Reflect on the x-axis. What's my mapping? Mapping is easy from the equation because if it's not in here, it goes against my y's, right? Okay, and then if I look at b is y equals f of negative x. What is that? A reflection in the y-axis. My coordinate is xy becomes negative x comma y because it's with my x, right? Okay, you sketch the two graphs. Sketch them in different colors. If you don't have different colors, sketch one with like stars as your coordinates and one with like boxes or something. You're going to label the graphs anyways, but it just makes it a little easier to do. Yeah. So we did the mapping of both of them. Now, you could get away with just trying to do the reflections like over the x like this, which you can, and you could do this way, which you can. The problem is that I'm going to add stretches to it, and then we're going to put them all together. So we have to get our mapping down really solid so that when I put them all together, it's just easy for you. That's it. So, we're going to look at these. We need to figure out what's happening here. They're reflecting, because why? We're in the reflection lesson. It's kind of a giveaway. Yay. How do we tell which axis it's reflecting on? What's helpful?
y-intercept.
Yeah.
The same x-intercept.
On the, yeah, the same y-intercept, it's on the x. Yeah. So if your invariant point is on the x-axis, like this one is, that means everything up here is going down here, everything down here is going up here, and this is staying. Or we could say, hey, this is negative 1, 0. My y's are staying the same, so then that means my y's are reflecting. If my y's are reflecting, it's about the x-axis, right? So here it says the graph drawn up in the thick line is a reflection of the graph drawn in the thin line. Write the equation for each. I should have given you an equation. So let's say this is y equals f of x. What's this one now going to be? Y equals negative f of x, because my y's are being negated, right? If it's affecting my x's, it has to go in here. If it's not, it's going to be outside. Now this one is a reflection on the y-axis. So if this is y equals f of x, this is now y equals f of negative x. And it's so important to understand horizontal and vertical translations by themselves and reflections by themselves and understand them. Not memorize, understand them fully. So when we throw them all together, it's not like, it's, oh, this is so overwhelming. You're like, oh, I got this. I know this, 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 this. I know my rules. This is easy, right? So you need to know your basic rules really, really well. So when I throw them together, it's not hard or overwhelming. You know what? I'm being nice. Do this. Do stretches tomorrow. We'll throw them all together on Friday. I mean on Monday, because who wants that on a Friday? No one. So we'll do stretches tomorrow, and then we'll throw them all together on Friday.